Welcome to our discussion on speed and velocity. So speed, what is it? It is the ratio of the distance an object moves to the amount of time the object has been moving. It is literally the distance over time. So we're going to take distance divided by time to come up with a speed. Average speed. Average speed is the total distance traveled divided by the total time to travel that distance. The average speed is going to equal the total distance divided by the total time, or speed equals d over t. Except we have to add up all the distances that the problem gives us and all the times that the problem gives us to come up with a d and a t to divide with.
While traveling on vacation, you measure the time and distance you traveled. You traveled 35 kilometers in 0.4 hours, followed by 53 kilometers in 0.6 hours. What is your average speed?
So, in our problem, we have to look at the total distance traveled and the total time that it took to travel that distance. In our problem, the person went 35 kilometers in 0.4 hours. Then the person went another 53 kilometers in a time of 0.6 hours. So to find the total distance, what we need to do is add 35 and 53. To find the total time, we need to add 0.4 and 0.6. So let's do that really quick. Five plus 3 is 8. 5 plus 3 is 8. 88 kilometers. Our time, 0.6 hours plus 0.4 hours. 0.6 plus 0.4 is going to be 1.0. Now we just plug our time and distance in for our time and our distance into our formula. So we have average speed equals total distance divided by, and I do want you to write these formulas all the way out as you work, the total time So we'll put in for our distance 88 kilometers. And we're going to divide the 88 kilometers by 1.0 hours. And we come up with an answer of 88 kilometers per hour for our final answer. Now, I would like you to open your book to page 333 and try the math practice problems 1 and 2. And if you need help, remember, you can always come see Mr. Kramer. Instantaneous speed is the rate at which an object is moving at any given moment in time. Instantaneous speed would be what a speedometer would measure, or a police officer's radar gun. They are going to measure the speed at an instant in time. So keep that in mind as you begin to drive, that instantaneous speed is what a speedometer measures and what police officers measure, not your average speed. Now we're going to look at some distance and time graphs. So on the y-axis, we have the distance in meters. On the x-axis, we have the time in seconds. So, can you tell me which one of these lines is the fastest moving object? If you said the red line, you would be correct, because it covers the greatest distance at about 60 meters in the shortest amount of time, about 3 seconds. If you look at the slope of all the lines, the red line has the steepest slope. Slope is an indication of the velocity of the object. If you have a really big slope, a really steep line, that's going to indicate a very fast velocity. Here's an interesting distance and time graph. So, as we travel from A to B, we are moving at a constant velocity. But what happens when we get to point B? If you said that we speed up, going from B to C, you would be correct. But then even something more interesting happens at point C. The line is flat. It has no slope. If slope is an indication of speed, and the slope of the line is 0, then the speed or the velocity of the object between points C and D on the graph mean that it's not moving. It has a velocity of 0. If you look at the distance, it's not going anywhere. It's not getting closer to the start line or further away from the start line. It has actually come to a complete stop. Then as we go from D to E, the slope's negative. It's getting closer to the start line. And when it reaches the x-axis again, that means the object has come back to the start line. Here's the anatomy of a distance graph, all the different parts we will look at. The accelerating part we will talk about in our next film, so we'll ignore this first chunk of the graph today. However, pieces from the graph we just looked at. Straight line at a constant speed, horizontal meaning stopped, steep lines meaning it's going fast, and lines that go downhill or have a negative slope, meaning that it is moving back towards its starting position. Now, velocity. I've used that word a few times throughout this film. Velocity is a speed with a direction. That means it is a vector. Vectors have a magnitude and a direction. So velocity is going to have a magnitude. That's its speed component. How fast is it moving? And the direction, is it moving north, south, east, west, up, down, left, right? That's important in indicating which way the object is moving. If we go back to our graphs, you notice the direction is indicated in the slope by being positive, as in this part of the graph and this part of the graph. Positive means it's going away from the starting line, or negative slope, meaning that it's coming back towards the starting line. And we can also add vectors. Combining the vectors, this is where we're going to get into how to add the vectors. When going the same direction, you want to add the velocities. For instance, if you're driving a boat down the Mississippi River, the river is flowing at 5 meters per second to the south. You are driving to the south at 5 meters per second. Your total velocity vector is going to be 5 meters per second south plus 5 meters per second south, or 10 meters per second south. The river is actually going to help you move quicker. If you are going back up the Mississippi River at 5 meters per second to the north, and the river is flowing 5 meters per second to the south, if you add those two together and use negative for south, you'll get 0. Or if you subtract, because you're going in the opposite direction, you take one minus the other, you will still come up with 0. What does that mean? If you said it means that you have no total velocity, you are going as far or as fast up the river as the river's pushing you back down, that means you're not going to go anywhere relative to the shoreline. I hope this video has been helpful for you to understand vectors, speeds, and velocities.